Hello. So if I'm not here, they will not see me. Thank you very much for coming. This is the moment I forget everything I had to say, which is good. So I will start with the sponsors. Monzo is sponsoring this meetup. A big round of applause for Monzo. Thank you. So they're not only giving us this space, not giving us like using it. They have live stream. Finally, my mom can see me. And pizzas and drinks. So thank you, Monzo. Hope you don't put it in my car. So first things first. Finally, we are more than 3,000 members of the Kubernetes Meetup. I know, you're not very impressed. However, it's 10 times this. This is us. He is more like me, but hey. So this is the agenda. I think that Marcelo said already that Liz could not make it. Another time. So David McKay is going to talk about influx instead. Now, I was going to do something with Liz, but it didn't happen because she's not here. So then, so I was going to suggest to do a dance, but then David came along and I thought, I'm not sure if I should do the dance with David because, you know, these things. But then, no dance, but we can sing a song if you want. No, I know. Okay, after David McKay, we'll have pizza. And then Miles will talk about Monzo and doing things in a banking with Kubernetes. And finally, Charlotte will talk about devs and ops and the parentheses in between. DevOps London, DevOps Day London, September. Other meetups, the Docker meetup. Everything happens around that week, the first week of March, second week of March, I don't know, first one. Where are the Just Hackers? Come here. Come on. Dude. So Just hey. Hi, nice to meet you.
Nice to meet you.
So you are doing training.
We are. We're doing training.
Good, good. And you're giving away 2 tickets.
And we're giving away 2 tickets.
Thank you.
Anything else?
How is it going to work? Do you want me to give them or you want chase him?
You can decide.
Yeah. Oh, really?
That's smart.
Okay, I'm selling them. No, I will not sell them. Why? Okay, I'll give it to my good judge.
You can be the judge.
Okay, like, no? So finally, one last thing. Oh, this is very important. Yeah. Yeah. We're planning on doing Kubernetes deep dive. We're going to start with security. It's going to be a slightly different kind of format. And yeah, however, I'm not sure how we're going to announce it, so stay tuned. Ta-da. After this, we will go to the pub, as usual. Someone has suggested the flying horse, which usually is a Pegasus, but maybe the people that didn't know. And that's it. Be kind, please. And thank you, David, for coming and covering up Liz with such a short notice. Thank you. Do you want me to do the intro? No, you do the intro.
There's an intro?
Like introducing.
Started. So as I said, I've not been with InfluxDB very long. And Ivan was very careful when he asked me to do this talk. Other than saying, Dave, I'm really desperate, can you do a talk? He then finished up with, you can't do a sales pitch. But InfluxDB is an open source product, so what the hell am I selling? I'm not really sure. But I love containers and Kubernetes. So joining InfluxDB for me is a very exciting product because the release of 2.0 is built to work on Kubernetes. And that's kind of what I want to show you today, as well as a brief introduction to 1.x for anyone that isn't familiar with the product already. So I ran a poll last week asking anyone that runs Kubernetes, how are they monitoring it? So let's just, by a quick show of hands in here, do the same poll. Put your hands up if you monitor Kubernetes. I hope the hands down don't run Kubernetes. But what I found interesting about this poll was that Prometheus is obviously the market leader in the Kubernetes landscape, but that's fine. But 13% of people would rather not monitor their infrastructure than use InfluxDB or Prometheus. You know, Datadog, I can understand. New Relic, I can understand. You've got to pay a lot of money for these products. But 13% just went, meh. And if you're in this room and you're part of that 13%, right, I really want to show you how easy it is to deploy one of these solutions and monitor your infrastructure. There are no excuses. So first, we need to do a little bit of demo prep. And the reason that I'm going to do this now rather than doing it later is because A, I want you to know it's real. And B, I want there to be at least 5 minutes of data by the time I get to the demo. So first, we're going to deploy Influx 2 to our Kubernetes cluster. I know that's maybe not large enough. So we're just doing kube apply, and I'll show you the manifest in just a moment. And at the same time, I'm going to run this create Telegraph script, which is going to deploy Telegraph to our cluster as well, and I'll tell you what that is in a moment. As far as what these scripts are, our Influx 2 YAML is a very simple deployment, which is running the 2.0.0-alpha build, which was built very recently. And we're exposing a port 9999. As for the Telegraph, I'm using the Helm chart. So this is the stable Telegraph. I'm not using anything that is alpha or beta at this stage. And it is configured with a few plugins. We'll come back to the specific configuration in a little bit. So what is InfluxDB? It is the modern engine for metrics and events. By metrics, we mean monitoring our infrastructure, and by events, we're talking about things that happen within our infrastructure. Metrics are really, really simple. We all know what the load average is, memory usage. If we have unscheduled pods and the request latency of any sort of web application, etc. Right? These are generally numbers with a label that tell us something is happening within our infrastructure, or at least the rate at which it's happening. Events, on the other hand, provide a description of why certain numbers may be the way they are. So if we are running Kafka in our infrastructure and compaction has started, we might start to see some correlation between latency or load on any of our machines. If a VM dies, we might start to see some unscheduled pods. That number is going to increase. And if someone deploys a new application, you might see the request latency of your application skyrocket or get a lot better depending on what they changed. But it's not until you actually start to visualize these things together that you can truly understand what's going on within your infrastructure. So it's okay to monitor, and you'll get a lot of benefits of that, and you can build automation around it. But it's not until you correlate those metrics with things that actually happen, tangible events within your infrastructure, that you can actually start to build more sophisticated monitoring and alerting and automation on top of all of that. And that's what InfluxDB wants to provide. Not just a system where you put time series metrics, but time series events. Did someone deploy something? Did a pod die? Did we lose a node? All of these things are crucially important, and joining them together is how we get sophisticated infrastructure. Excuse me. So this is a little bit of blurb from the website. I think it's important because we want to observe, learn, and automate. This is what we want from the infrastructure that we provide, at least the monitoring that we provide. Nobody likes to do hand-rolling of anything, and InfluxDB can provide the layer that you need to do both. And that's provided by the tech stack with all of the mascots from each of the products. So if you're not familiar with the tech stack, we've got Telegraph, Influx, Chronograph, and Capacitor. And the logos, we'll remember the names when they come up in the slides because I've not got that down yet. The first one is Telegraph, the tiger. This is how we collect metrics. Telegraph is a binary that you can run on a physical bare metal machine. You can run it in a namespace on Kubernetes. And it will actually go out and fetch metrics from anywhere that you want. It can fetch log data from files, so syslog, any container logs within your infrastructure. It can also speak to Kafka, to MySQL, to Postgres, to Mongo, et cetera, et cetera, et cetera. The list of plugins and applications that Telegraph is capable of monitoring is a very high number. So anything that you need to get metrics from, Telegraph is the one that does it. And it will send them to Influx. What's really cool, and what makes this a little bit less sales pitchy, is that the output plugins in Telegraph also go to Prometheus, and to Kafka, and to MySQL, and to S3. So Telegraph is part of the Influx stack, but something that you can use within your infrastructure without ever having Influx installed yourself. Next, we have Influx itself. I think you pronounce this bird Eevee. I may be wrong. But this is the actual time series database itself. And this is the extremely alpha thing that we're going to try and play with in a minute. Next, we have Chronograph, the giraffe. This is like Grafana, but as part of the Influx stack. They're very, very similar. You do not need to use Chronograph. You can use Grafana. And both support pretty much the exact same tool set. The only thing that changes is with 2.0, we bundle this all together, and we'll touch on that in a minute as well. This is kind of what some of the dashboards look like. What's really, really cool, and Grafana have actually done this recently, so it's a little bit less cool, is that we allow you to visualize your log data with next to your metrics. This is the idea of correlating metrics and events within your infrastructure. So when you see a spike on a chart and your CPU is going through the roof, being able to see the log data or the event data that happened at the same time is going to tell you exactly what happened and why, rather than just what. And finally, we have Capacitor. We're not going to talk about this too much because it's half dead and half not. As part of the 2.0 changes we're going to talk about, Capacitor no longer exists as an external entity, but the functionality has been embedded into the database itself. So that was 1.x. We're now going to take a look at 2.0. So everything is a single binary. And as you can tell, InfluxDB really like their animal-based mascots. And although I don't have much influence yet, it's only been 6 weeks, I'm really keen to push through a logo for 2.0. If you've not seen South Park, this is Man Bear Pig. And I think it is a nice amalgamation of all the products that we have. So leave it with me. Hopefully that happens. But what makes 2.0 really special is that it's multi-tenant out of the box. So you can create organizations within Influx to keep isolation between your databases. One of the problems that 1.x had was that the APIs across each of the products that we just discussed were very, very similar. Now they're able to consolidate that into a single API with a Swagger definition, and there's a lot less duplication of code between all of the surrounding products. So maintenance and the velocity at which Influx is going to change is hopefully going to increase over the next 12 months. We're now also starting to provide official client libraries, which Influx has never done before. We have a list of languages that we plan to support on the release, some probably the end of Q1, so March to April. And as I said at the start, the point of 2.0 is to understand Docker and Kubernetes, right? We understand that now Kubernetes is ubiquitous within most people's data centers. And we don't just want to understand it, but it wants to be powered by Kubernetes. And what I mean by that is that all of the core infrastructure within the new Influx is also running on Kubernetes. And why is that important? Because if you're having pain points by running Influx in your Kubernetes infrastructure, we're having pain points as well. And we're going to fix that. And that's our plan and our strategy over the next 12 months. The other thing that I want to kind of briefly touch on is that we have released a new open source language to the world. We're calling it a data scripting language, and it's called Flux. And we're going to take a little bit of a look at the syntax. The first thing you'll notice here is that it's functional and uses the pipe forward operator. We have a from statement, which takes InfluxDB buckets. So in this case, we're calling a bucket called Telegraph Autogen. We're using a range parameter to filter the data to a specific range. And then we're going to filter all of that data based on a measurement and a field value. We can then aggregate that to sum up the values within the window and territory to get a look at the infrastructure. So it's a very simple language. There's not a lot in it at the moment, but we have great plans for what we want to do with it. It is available now if you're running 1.7, and it is available in the 2 alpha. If you've worked with 1.x, InfluxQL will be able to be transpiled. So any existing code that you have can be converted to Flux for you. And it works in Chronograph and Grafana already. So if you're already using Grafana and you want to start playing with Flux to query your data sources, then you can. As I said, we have great plans. We don't want Flux to be an InfluxDB language. We want it to be a data language. That means supporting Prometheus and Kafka and S3 and any other data store that we can build a compatibility layer for. So we want to provide a single language where you can pull your data together, aggregate it, and visualize it with Chronograph. That wasn't too sales pitchy, right? So we're going to take a look at the stack now, assuming they're deployed. So as part of the deployment script, I also deployed an Envoy. The reason I did that is I want to show off the Prometheus integration with Telegraph. I said that it can collect metrics from pretty much anything. And this is using the Prometheus integration. We have our Telegraph deployed and our InfluxDB deployed. So the first thing I want to do is just do a kube control port forward to the service. And I'm exposing the port. And if we get lucky, this is the welcome screen to Influx 2.0. So there's a little bit of setup at the start where I can't even spell my own name. And when I said multi-tenant, it's asking for an organization name. I'm just going to use my own. And the default bucket, which is what the retention policies are applied to, is going to be default in this case. And by retention policy, what I mean is InfluxDB can add a TTL to your data and expire it after 30 days, 1 hour, whatever you want it to be. A very common pattern, and something we expect Flux to fill the gap for here, is to take your buckets with the shorter time to live, round and aggregate those metrics up and put them into a longer TTL as well. If anyone wants to talk about that, we can do that later. So we set it up, and now we're going to jump into the quick start. So if I click on the Data Explorer, then at the bottom left, we can start to browse the metrics that we've collected in the last kind of roughly 10 minutes. If I type kube, that's not a good start, is it? Let's see what went wrong. Did I mention this was alpha? We'll take a look at some metrics that we do have to source. So I think what's really cool here is we can browse the metrics that we have collected. Right now, that is just the internals of InfluxDB. What I think is really interesting here is that InfluxDB exposes its own metrics in the Prometheus/Open Metrics format, and it actually consumes them itself. So it has first-class support for that format and pulls them in. If we want to take a look at the number of buckets, I can view it as a counter, and I hit submit. We can see that we have one bucket, and that's because that's the bucket I created. And what I'm just going to do quickly is create one more bucket. So I'm just going to use the dashboard here. We'll call it bucket 2. And if I click on scrapers, so this is a new primitive within Influx 2.0. The Influx binary itself can scrape Prometheus endpoints. This is the local one I was talking about, so it's scraping itself. You can add other Prometheus endpoints here, and it will scrape them for you, or you can use the Telegraph Prometheus plugin, and we'll look at the code for that in a second, even though it's not working. And now on my dashboard, we can see that because I created a new bucket, it's went up. Now, that's not very exciting, but I just want to give you a feel for what Flux is and how it works. So you can see with this query builder, it's really intuitive, really simple. I click on the metric, I can filter on a field. What it's doing behind the scene is providing a Flux query for us that we can then modify. So I don't want to use the dashboard time that's provided here, so I could just say that I want to collect all the metrics for the last 5 minutes and use a time literal for that. And my graph gets a little bit shorter. If I change that to the last 1 minute, we should hopefully only see the 2 value. So we can start to use time or duration literals within our Flux query. Obviously, we can remove some of the other counters, which might break it. No, that's OK. And we get really great documentation from the right-hand side. So we can actually look at all of the functions that are available to us, from selectors to aggregators to inputs and windows. and get live documentation. So this is the big part of our strategy for 2.0 is to make Flux ubiquitous with data scripting and to make it really easy for anyone to use this language, especially with data sources that aren't necessarily in FluxDB as well. We're also focusing on just ease of use. So when you come here, you can actually say that you want to create a new configuration within Telegraph. I can say that I want to use my default bucket or bucket 2, and I can say what I want to scrape. So here I could say Kubernetes, Docker, and my system metrics. I hit continue. I can give it a name. Docker does require a little bit of configuration, so I need to tell it where the Docker sock is. And Kubernetes requires the API server. We're using the downward API here, so I can just do host IP 102.50. And that's all the configuration I need. I can then click create, and it's going to give me a token, which I can then stick as a secret or into my vault somewhere, and a command that my Telegraph can then use. So you no longer have to provide complicated configurations that I'll show you in a second, but you can use the GUI to deliver that configuration to your application. And this is the bit that didn't work. Not that I'm going to feel bitter, but these are the input plugins that I expected Prometheus to grab for me in the last 10 minutes. So I wanted it to pull in the log data from all of my pods. I configured it with the Kubernetes API server so that I could get pod metrics and container metrics. I also configured it to scrape my Kubernetes cluster and pull out all of the Prometheus annotations. So the Envoy that I deployed has the Prometheus scrape annotation with the port, and Telegraph will respect that and pull that data in for you. And finally, I had the Docker configuration with the sock and a scrape interval and so forward. And that should have made a really cool dashboard that we could have had to play with. The one thing that I can't show you because it failed miserably is that we offer pre-canned dashboards. So when it detects you have Kubernetes metrics, Docker metrics, or logging data, it's going to create a pre-canned dashboard. So you can just say, show me my Kubernetes cluster, and you get a bird's eye overview of everything happening with the log data on the bottom. I will try and fix it, so if anyone is around later or at the bar, please come and speak to me. I'd be happy to do a demo that might actually work. But thank you very much for your time.
We are not going to do questions because I don't know the answers, but pizzas are there. Go and help yourself. And if you have any questions, grab him later and ask him, and write a blog post or something.
Hello, hello, everyone. Just a 5 minutes like check. So it's currently 20 to 8. We are going to be starting the next talk, which is from Miles in 5 minutes. So thank you.
I like. Can people come back to their seats, please? Thank you. So we have Miles. He's going to talk about building a bag with Kubernetes. How many YAML lines do you need to build a bank in Kubernetes?
I reckon about 1.5 million, something like that. Yeah. Give or take.
Would it not be better to do it in JSON? Well, ladies and gentlemen, Miles, thank you very much. No, it's mine. Sorry.
Hello. Welcome to Monzo, and happy Cubentines. And I hope you will find time to appreciate the infrastructure that sparks joy in your life. I'm Miles. I'm an engineer on the platform team here at Monzo. And as you might have guessed from the title of the talk, Kubernetes is a pretty core part of the platform and what we do. So a quick recap on Monzo, if you're maybe not aware. We're a bank aiming to improve everyone's financial lives by building a banking app that doesn't suck. We've got a ton of features to help you sort of budget and control your spending, instant notifications, sending and receiving money easily, being able to split bills with your friends, and much more. We also have these really brightly coloured cards, which, contrary to popular belief, isn't actually pink. They're actually hot coral, technically. So I've been working at Monzo for about 8 months now, and I've been a customer for just over 2 years. And I actually signed up shortly after reading this blog post called Building a Modern Bank Backend back in September 2016. It's this really interesting sort of blog post about an ambitious startup using microservices and Kubernetes to build a bank. There's actually a follow-up talk that Ollie, our head of engineering, did a couple of months later about using Kubernetes to build this bank. And it was a pretty different time because we had about, according to Ollie, about 70,000 prepaid cards which have been issued, which actually seems like quite a big number looking back. We now have over 1.5 million customers with current accounts. We've also grown from what was kind of a handful of engineers to just over 120. So pretty different times now. So this talk is really kind of the volume two of Ollie's talk in 2016. Just kind of reflecting on those decisions, how Kubernetes is working out for us, and what we've learned. But first we'll take a step back and talk about what we kind of mean by a modern bank backend. And what we kind of actually want from that. So this is a photo of IBM mainframe. And this would have once been considered the kind of state of the art in banking technology a number of decades ago. And these machines, or at least their modern equivalents, still actually power a lot of major banks. That's a bit of a problem. There's a lot of kind of overnight batch processing, daily tape backups. And they're these huge kind of scary legacy systems. They're really expensive to do any kind of change on. They're really risky to do any kind of change on, as TSP found out last year. And they meant that kind of banking technology and customer experience has really sort of lagged behind in the last few years. And of course, it's really easy for me to kind of stand up here and say that because at Monzo, I've kind of had the luxury of being able to kind of build our banking architecture from scratch using sort of modern technologies and tools. So yeah, what do we actually need? What are the requirements of modern bank backend? So firstly, I mentioned with the mainframe, they're really difficult to change. We know the system needs to change a lot all the time. And we've kind of gone from 2 years ago just having the sort of prepaid card to now we've got a fully featured kind of current account. We've had to ship a lot of code in that time. And of course, we're still building out features. This is a recent integration we did with Flux, where you can get itemized receipt in your app if you go and shop at, I think it's Pret, Eat, Itsu, or Pod. So we're building out a lot of these kind of features, so we need the system to kind of be extensible. Other than kind of shamelessly trying to plug our product features, yeah, that's the point I kind of want to make. We want to build on the system without it kind of descending into this horrible monolith. We also want the system to scale. We're signing up a lot of people every day. So we want to try and avoid kind of having to do too much re-architecture or kind of intervene to constantly be rewriting stuff so it scales. Security, very important. People trust us with our money. If we lose that money, people are not going to trust us with that money. So our system needs to be easy to secure. We also want our system to kind of not rely on these kind of overnight batch processes and actually process a lot of stuff in real time. So that if you're anything like me, it can tell you off when you're kind of spending too much money on lunch. It's also pretty important for sort of fraud detection and monitoring as well. It's a great story I saw recently where our system kind of blocked a transaction that was made with kind of stolen card details. This isn't really unusual because obviously every bank kind of has to have these real-time fraud detection systems. We were able to send a push notification to the account owner within a few seconds to let them know that that someone had tried to use their card. I think that's a really great customer experience. And availability is really important too, especially as we're an app-based bank. I think people should be able to access the money and their kind of account services 24/7. We have a lot of customers who are kind of traveling around the world, so they might need to kind of check their balance at whatever time of day. Like I said, the legacy bank systems are difficult to update. In this particular example, we need a 2.5-hour maintenance window just to wind the clocks back. So we want to kind of avoid this and avoid these maintenance windows. It's also reliability comes into this. We want to avoid kind of unplanned maintenance windows, if you like. So this is the architecture that we built up to kind of do these things. And I'll go through it bit by bit. But given the requirements I've just kind of listed, a microservices architecture kind of lends itself quite nicely to a lot of these problems. We can scale things up independently without having to rewrite too much code. Also scales very well with the number of engineers. It's a very kind of extensible system. So you can have kind of multiple teams working on different parts of the code base. And we can deploy kind of multiple instances of each service to make them kind of highly available. So we do run the majority of our infrastructure in a Kubernetes cluster running in AWS across multiple availability zones. So we run our kind of microservices in Kubernetes. We also run a few other kind of important components like Kafka, Elasticsearch, and Prometheus. And we've also got this kind of service mesh layer using Envoy, which gives us the kind of intelligent load balancing and the ability to retry failed requests. So that comes into the reliability. We do still run some systems outside of Kubernetes. For example, Cassandra, our kind of main database, and NSQ, which is another messaging system. And actually, we do have some stuff outside of the cloud, you might be surprised to hear, in a couple of data centers. And the reason we need these is we're a bank, so we have to connect to various payment schemes. So for example, MasterCard, we process kind of card transactions through and a fast payment scheme, so we can do bank transfers. And these systems were designed in a sort of different era before cloud, and they haven't still fully kind of found a way to work with the cloud. So they sort of give us this cable, and they go, here you go, plug this into your system. So we need some way of getting that kind of from the data center into our infrastructure. And as a general principle, we've found we want to do as much processing within Kubernetes as we can, because it's much easier to update, kind of redeploy a service in Kubernetes than it is to like swap out something in the data center. So there's actually very little in these data centers other than just being able to like securely proxy requests through to our main infrastructure. And amazingly, if you look at the kind of fundamental components here, and you look back at Ollie's KubeCon talk a couple of years ago, very little has changed. We've still got the main kind of Kubernetes service mesh layer. So I think it's worked out pretty well for us so far. But what are some of the kind of other things that we've learned? So it's definitely sort of extensible, I think. I think starting out with a kind of microservices architecture on top of Kubernetes, when you're this very kind of young startup with not many engineers, is a pretty bold move. It sounds like a lot of hard work and kind of extra kind of overhead. And more importantly, it takes a lot of kind of time away from building actual kind of useful producty things. So it's a pretty kind of bold decision, but I think it's been kind of more than justified 2 years on. Even with 120 engineers, which you have now, we're still able to ship things at a really kind of phenomenal rate. Hasn't sort of slowed down. And obviously there's a lot of other factors in this. I'm not just saying you could spin up a Kubernetes cluster, throw a load of engineers at it, and it'd be kind of productive. But I think Kubernetes does play a pretty big part in this. It allows us to kind of abstract away all these problems that kind of engineers shouldn't really need to kind of care about in their day-to-day work, like worrying about like which particular bit of infrastructure their service is going to run on, worrying about kind of networking or how their service is going to kind of route a request to another service. Something else we've learned is any kind of system like this, you have to have observability. And what I mean by observability is that we're able to sort of infer and dig into the behavior of the system. And we use tools like logging, distributed tracing, and as I've got here, metrics. And this is a graph from one of our most important dashboards. So when you go to a shop and you want to pay for something with your Monzo card, you tap it on the card reader. That card reader then sends a request via the MasterCard network that comes into our systems and then goes, should this payment be allowed? Has this person got enough money? Is this potentially fraudulent? And what this graph here represents is the latency of our internal systems that make that decision. And it's extremely important to us that we make that decision very quickly. If this latency starts creeping up, eventually we're going to get to a point where transactions start failing. And then we're not really kind of fulfilling our duties as a bank, so people can't use their money. And another reason it's important to have like this observability is in that kind of critical path of making that kind of MasterCard transaction. There are about 40 or 50 services involved. That sounds like a lot, but these are all doing things like storing the raw kind of message formats from MasterCard, so we can go back and debug them later. They match the card number against an account we have and reject the payment if it can't find a card. It checks the balance to make sure you obviously have enough funds, and does kind of fraud checks, and most importantly, kind of inserting a transaction onto our internal banking ledger. So if this latency kind of shoots up, we need to work out which one of these 40 or 50 services is actually responsible. And given that card transactions would be actively failing, we'd need to do that quite quickly. So I've shown a pretty rosy picture of Kubernetes so far, and it's in general it's great. But I think any kind of complex system with a lot of automation, things have the potential to go kind of really wrong. This is a really interesting GitHub repository that you might have seen recently. It's got a collection of kind of blog posts, articles and talks, postmortems, basically a load of stories about Kubernetes failing. Unfortunately, Monzo is on there with a pretty bad outage we had back in October 2017. And this is a kind of a story of a classic kind of cascading failure and a like perfect storm of bad interactions between components. Unfortunately, I don't have time to tell the kind of full story, but Ollie did a talk at KubeCon last year called Anatomy of a Production Outage, where he talks about this in a lot more detail. Definitely go and check it out. It's linked on the GitHub repository here. But in summary, the kind of basic quick story is that we upgraded etcd, which is the main kind of backing database for Kubernetes state. And then 2 weeks later, someone did a routine deployment. Very, very kind of small change. And this triggered a particular bug in the Kubernetes API, or in fact in the etcd client in the Kubernetes API. And this in turn triggered another bug in Linkerd, which we were using for our kind of service-to-service communication at the time. And at this point, things were not great, but still okay. And unfortunately, we decided that trying to restart all the Linkerd pods would help the situation. Unfortunately, none of them came back up cleanly, and no servers could talk to each other. Luckily, I wasn't a Monzo at the time, but it didn't sound like a very fun day out. But I don't think kind of Kubernetes is itself kind of inherently prone to these kind of failures. I think any kind of system that has these kind of complex interactions between components and lots of automation could be kind of susceptible to them. But I think Kubernetes does make it much easier to build up and deploy these kind of like big systems. So something else that's really helped us is a decision, or the way we deploy Kubernetes. We deploy Kubernetes the hard way, and if you're perhaps not familiar with Kelsey Hightower's excellent tutorial, what I mean by this, we set up our certificates, we provision our certificates, set up and install all the components. We do automate it, but we don't use any kind of like managed solution or even like an automated tool like COPS or kube-admin. And at the time when we started using Kubernetes, it was pretty early days. I think it was 1.2 or 1.3. Managed services were pretty much in their infancy. I mean, it might have been kind of GKE at the very start. COPS and kube-admin basically non-existent. So I think this was pretty much our only option. And I highly suspect, actually, if we were to start from scratch now, we would seriously consider using kind of one of the managed tools or an automated tool. But a huge kind of benefit we've got from this is that we have a really kind of deep understanding of how Kubernetes works and how all the kind of components fit together, how to run them. And this has been really kind of valuable when dealing with the outages we've kind of seen before, and even kind of issues that pop up every now and again. So if you are someone who works with Kubernetes, especially if it's a managed or like a managed solution or an automated tool, I'd really recommend taking some time just to go through this on your own, just to learn a bit about how the components fit together, and at the very least, you might gain an appreciation of how much money you're spending on your kind of managed provider. So that's kind of all I have. Just to kind of sum up, Kubernetes massively helped us build this kind of modern bang backend, and really helped us kind of scale and be able to kind of build on the system. Observability is really important. When it goes wrong, Kubernetes can go kind of really wrong, but running Kubernetes the hard way has helped us understand how to fix it. Okay, thank you. Before we kind of get on to questions, I'm going to do the obligatory hiring pitch. We're hiring. Sorry, Van. We're hiring. We're looking for engineers in a wide variety of roles, from kind of mobile to backend to platform, if you're interested in working with things like Kubernetes. We're also looking for engineering managers. If you are interested or you know someone who's interested, you can speak to me or Marcelo, give us a wave, or Greg. Yeah, cool. Can I do some questions?
We're not doing questions because we are late. So if you have questions, you stay until later, and then you talk to him. Or you can talk to me, but I'm not going to answer. If you want to have a Monzo card, I have a URL that I can give you, and then they give me £5. You said that you were going to give me 6 if I select. So yeah, we're a little bit late, so no questions. Hope you don't mind. And now for the next speaker, Charlotte. I just want to say, while Charlotte is setting up, I just want to say, oh, this might be it. Oh. Miles. Like, Marcelo was going to do the pitch about hiring staff, but yeah, it's you talk to each other now. And you need like the you want this?
Yes, it's this one. Hello. Today I am talking about Kubernetes dev and ops. I come from more of an ops background on this particular topic, and this is sort of something that's not covered quite so often. So quite often what I see in Kubernetes talks is talking about the big migration. So you might find this story familiar. Company A had a really bad developer process. So they had some kind of monolith, or their developers just hated the whole code base, and they hated deploying, and they hated talking to ops. And then they discovered containers, and they started using them. And that meant that they could share things around with each other. They didn't have any problems with like dependency management because it's all locked down in the container. But like that changes your entire process, and it means that like ops have got to do some work to try and catch up with you. So one of three things tends to happen. You start building your own orchestrator if you've got like enough money, or you're kind of a psychopath. Or you found another one that was out there like Swarm or Bezos and Marathon. This is sort of like pre-Kubernetes coming out, or you might have been a little bit earlier on in Kubernetes development. Or you flung Docker Compose into production and hope for the best. And then we're deciding that all of that was a really terrible idea and moving to Kubernetes because it's, I don't know, the new hotness, whatever. And if you are at this point, like this exact point where you're sort of teetering on the edge of thinking about what to do with your infrastructure, I would recommend Alice Goldfuss's talk called The Container Operator's Manual, because she talks a lot about the stuff that you should really know at this point in your infrastructure development. But something I specifically wanted to talk about within that talk was the fact that she mentions that you should build an entire new team to handle Kubernetes, which I completely agree with. But the catch is that, particularly in this kind of company, all of that sounds kind of difficult. For one thing, Kubernetes is shiny and new. It's difficult to hire people who are like ready-made Kubernetes engineers, know how to run it, know all of the quirks, and know it from an operator's perspective. From a development perspective, it's kind of a good thing in terms of the way that infrastructure works, because if you move a developer from Kubernetes, from using the Kubernetes API in one company, they can probably work in another. But from a ops perspective, infrastructure can be really messy. And depending on where you've come from, where your company has come from, whether you're greenfield, whether you're using GKE, like it can be, there's going to be quirks in every single company. So even if you hire someone brand new who knows how to run Kubernetes, they're probably not going to know how to run it for you or within your infrastructure. And if you're going to take other people from other teams and form this brand new team, it takes a lot of planning to move those people around. They probably have prior commitments to that team. They probably have support routers that they're going to have to deal with. And they also probably need to learn how to use Kubernetes, so that's not a great solution either. So the result sometimes ends up being that you give it to the ops team that handled all of your other tooling for developers. It might have DevOps or platform in the title, depending on your preference. And the thing with this is that team probably has a huge pile of work already. To me, sometimes those teams end up being like you're asking like 10 people to play the work of an entire orchestra. And that's, aside from whether that's physically possible, the mental strain to actually do that is pretty difficult, because you've got to have like all of the context to be able to debug every single piece of your infrastructure. And you've got to be ready whenever it goes wrong. Even if all of your systems are up all of the time, like that's a lot of mental strain to be dealing with. And I have friends who are on these kinds of teams, and they say things like this, whereby I've learned to stop saying who's going to support this, because that means it's probably me. I've probably said that myself at one point. So how do you end up with those teams, aside from the Kubernetes aspect of this particular problem? And to begin with, too few are owning too much. I think you already get that picture from this story, whereby you simply cannot keep up with the amount of stuff that is in your backlog, the amount of services that you're dealing with. And I have like a few solutions to that. The main one is sort of like, if you were going back from trying to do this story again, I suppose, try and make sure that your concerns are narrower than just give all of your developer tooling to this one team. Like, and this kind of varies depending on your size, but trying to like keep track of how many different services you own and make sure you don't overflow that amount. Secondly, attrition. So every company is going to have to deal with the fact that your engineers will probably leave at some point. I think I read somewhere the statistic is like 18 months on average is how long your engineers are going to stay. On average. So if you're a really bad company or you end up with a system like this, you're probably going to have a slightly shorter amount of time. If you're really nice to your employees, you might have a slightly longer amount of time. And I have a few solutions to this one as well. The first one is be good to your employees. That's kind of a given. If you're like not nice to them, if you don't have a good environment like this one, then they're probably going to leave. But secondly, in order to kind of deal with the fact that they might still leave even if you're nice to them, you need to be writing documentation. I personally tend to, even on infrastructure projects, start from the point of view of writing down every single step of the way when I first set something up. That may work and not work in various different situations depending on what it is. And don't replace one person with another person. And what I mean by that is like if you're doing handovers when someone is leaving and you're trying to download absolutely everything that they have in their brain, don't just have one person who sat there trying to listen to them, because inevitably they're going to be like, wow, this person dealt with an awful lot of crap that I don't want to have to deal with, and I already have this backlog in my brain anyway. You should be trying to make sure like a few people have picked up different bits of what they were working on previously. And another one that tends to cause this problem is company reorganizations. So a lot of larger organizations I found, in order to address a problem, they'll reorganize. They'll decide, no, we need to be following the Spotify model, because that works so well in every single company. And it doesn't, and it shouldn't be called a Spotify model, as Spotify have repeatedly told people not to call it. And the thing is that, like, sure, from the outside, from a managerial point of view, if we were in this perfect greenfield world, maybe your reorganization would work. But a lot of the time, these happen, and you don't talk to the people who are actually going to be most affected, your engineers. So whenever you're doing that kind of work, you should be talking at all levels and in kind of psychologically safe environments about what their concerns are. Whether that may be how big the support rotor is going to be or how small it is going to be now. Whether that may be how much they're taking on or taking away. And whether people are happy with that or think that it's actually going to work. And finally, bleeding edge complicated tooling. Kind of relevant to Kubernetes. It is very complicated and it is difficult to operate, as I think we've already established. And as far as bleeding edge, if you don't know what that term means, it means that it's like so new that you're going to cut yourself by running it effectively. And that's not always true, that you're not always going to inflict a lot of pain on yourself, but you could do, because there's less knowledge about it, there's less people who are running it, et cetera, et cetera. And generally, you shouldn't be following hype-driven development, as in you shouldn't be going, oh, there's this new blog post that says Kubernetes is the new hotness, so I'm going to immediately run this. Like, I'm immediately going to switch over my entire organization to be running Kubernetes. So that story that I mentioned earlier about, developers doing this and that, and your infrastructure starts at this point and that point, it's not necessarily the worst thing in the world, to be honest, as much as I kind of made a joke out of it, because at least that means that you've thought about the way that your infrastructure is going to go. If all you need is Docker Compose in production, then fine, just so long as you've actually thought about it, rather than immediately saying, I have one container, so I'm going to run a whole Kubernetes cluster to look after it. Anyway, so none of that is particularly useful to you if you're actually already in this situation. And the first thing I would recommend if you are having this kind of problem is collect some data. This is the same for almost every problem in software engineering. So you should be talking to the team, whichever team it is, or whether it's your entire department, and assessing how many things they actually own. This might take you a while, depending on how many engineers you have, how many different teams you have with this problem. And you should try and be as honest about it as possible. There might be some people who are like, just running one service by themselves and they're not very comfortable with it, etc. And asking them how, whether they would actually be willing to be on call for those, providing support, whether that is actually by on call or in office hours, for example. And finally, repeat this every few months so that you know whether or not you're getting better at the problem that you have. Right, okay, so how do we, so now we've got that kind of process in place whereby we're trying to assess the problem that we have and face it head on. There's a few kind of different categories of things that I would recommend. The first thing is actual technical work. So these are going to be the things that your engineers are going to be doing. And the first one is encouraging shared learning initiatives. So I discovered probably about 6 months ago or so, something like that, this concept of a info dump, which was created by this guy called Sean Cassidy. And the idea is basically that instead of having a talk, you just have Q&A, because that should force people to drop out the things that they genuinely want to know. You no longer have to try and guess your talk topic based on every single person in the audience. And this is generally done internally, generally done by someone who is quite knowledgeable on a particular topic. And the topic could be about anything. It could be Kubernetes networking. It could be how you deploy within your infrastructure. It could be ELK. It could be whatever tool you don't know about, whatever area of a tool you don't know about. And the reason why this seems to work quite well is the people who know the most about the systems at your company are usually the busiest. They're usually the ones who aren't standing up here doing a talk because they just don't have time. Or they might not actually be interested in it. They might have problems with presenting these kind of ideas. So having a Q&A instead, where you don't have to do all that preparation and it's just people asking you questions, can take a little bit of the kind of fear away from it to some extent. There's sort of pros and cons to this approach. Most of the cons tend to be that the people who volunteer themselves to do these kind of presentations are still the ones who are a little bit more extroverted, and yet not always the ones that you want to be talking to. So yeah, try it out, see what you think. Secondly, introducing first line and second line support roles. So if you don't know about this concept, basically instead of having just on call, you would have someone who is a designated first line, who is generally the trainee within your team. So this is good for training up new ops people, training up people who might not be familiar with your particular area. And the idea is that all of the questions, all of the tickets go to that person, and they then refer to the second line, who would probably be on call, if they have any questions. And initially this can tend to make people go well, why don't we just send it straight to the on-call person who knows about everything? Why do I have to be the person who is a filter? And the thing with that is that if all of the questions are going straight to that, the on-call person, then they're constantly answering questions. You're not really learning anything because you don't know the type of questions that people need to know, and therefore you're not asking those questions yourself. Generally, the way that I would recommend running this is having it so that during the day, as in during normal working hours, your first line support person is handling those calls, and during non-social hours, you have the on-call person carry on doing what they'd normally be doing. That way, it's not it's kind of just you're taking a different role for a day or two. Thirdly, I would recommend writing case studies. So if you've heard of the concept of a run book, these are very similar. So a run book is basically where you have, in your monitoring infrastructure, you may have a bunch of alerts. You may have documentation for what to do if each of those alerts happen. And basically it should tell you like a relatively step-by-step instruction of what to investigate and what to do. And I think this concept works quite well because if you've written it down, if you've thought about it, you can probably get to the point where you can actually automate it and make it so that nobody has to deal with that problem again. So the concept of a case study is similar but not quite the same. This is more like if you've had an incident wherein something happened, say, I don't know, a pod got stuck in terminating, someone couldn't bring a service up, whatever it was. You make a note of every single step that you took to try and get to the answer to that problem. And eventually, if you did find out the root cause, you write that down as well. And anything else that you want to write about this particular problem. And the reason why I think this works is because, especially with Kubernetes, especially with complicated systems, there's many different paths that you could end up going down in order to try and find out what happened, find out why something is happening. And initially, when you first come to these kind of systems, it can seem very daunting to actually try and figure that out. And it can seem like you're never going to pick up enough knowledge to be able to answer these questions. So if you have everything written down and you get the rest of your team to do this as well, especially the ones who are a little bit more experienced, then you have sort of like a book of like ways this happened before. In particular, like I found that with when we started to write down the issues that could cause pods stuck in terminating, it helped quite a lot because like I tried Googling it and there's 1,000,001 different ways in which Docker can screw up, basically. The second category is like managerial work. So these are going to tend to be the ones that are a little bit more high level. They might take a little bit longer, and they're getting more towards the cultural side of things rather than the technical side of things. So the first thing is actually reducing the amount of stuff that you've got to deal with. This is the like one of the most important points, but I've put it under managerial because it will take you a while if you're in a big company. I quite like this quote because it sums up why I think that it's important to reduce the amount of stuff that you're going to do. Like, it's simply impossible for you to get 9 women to make a baby in 1 month. Like, throwing more money at it, throwing more people at it is not going to fix the problem. So, firstly, what we did in this particular situation was survey our users. So, find out who was using what tool, like what particular job they do, and share the results, because that can serve to sort of push the people who are using less and less of your infrastructure or using like older legacy tools that you may be supporting to migrate to like more easily supportable things. So straight away, just by sharing the results, you've managed to get people to stop using parts of your infrastructure, and that should reduce the amount of load that you're dealing with. Secondly, deprioritize tools which are used by low amounts of people. So even at the point where you've got, you know, where people are still insisting on using this particular tool that you want people to stop using so you can stop supporting it, you can kind of start to say to them, hey, look, this isn't really part of our area, or this is a tool that we've replaced with this one and we want everyone to move to that one. So it's going to take us a little bit longer because we've got more users on that one. So if you could help us by migrating, and you know, we'll happily support you with that, then that would really, well, it would help us and it would mean that you'd get faster support. So the third kind of piece of advice, or the second piece of advice that I've got under managerial is directing your support work so that everyone can see it. And by this I mean like within your organization. So like don't necessarily put all of your support work out there on the internet, whatever. And the reason I think that this works is because sometimes support work can just be people asking questions about Docker or asking questions about Kubernetes. And that doesn't always have to be handled by you. That can be handled by someone else who is also a subject matter expert. So in other words, more Slack channels is always the answer. So in this case, what we did is we had a Slack channel for each of our tools. And that means that like everyone can see the question, everyone can see the answer, and you might end up getting people who have had that question answered in the past and will do your work for you. It can also cause more problems, like that I wasn't actually being serious by that Slack would fix all of your problems. And in particular, this can cause a little bit more strain sometimes on your ops teams, because suddenly like people use Slack in different ways to which they'd use like Jira or ticketing systems. Some people just kind of fling whatever they're thinking about into Slack, and it's not great. And people will like fling stuff into Slack which they could easily Google, and that can mean that your ops team feel like they have to answer every single question. But like I said, it's directed so everyone can see it, so it doesn't have to be you that answers that question, and it's kind of better that people keep asking those questions so that they can pick up more knowledge in future rather than, keeping it to themselves forever. And then there's stuff that's more environmental. So this is more like changing the culture of your organization, changing the culture of your team. So in particular, be patient and kind to your users. I've had a lot of sysadmins be kind of nasty or like not want to answer questions, be the most unhelpful people in the world, and it sucks. And I genuinely do not think that grumpiness scales. And my reasoning for this is that if you're grumpy to a user, if you tell them like, I don't know, one-word answers, or tell them that they need to know this in order for you to answer that question, then that tends to mean that they ask you more questions, or they'll bug one of your neighbors in order to get you to answer the question. Because the question's not been answered, it just kind of continues the pain, especially for that user. So I do think that kindness does scale. And firstly, this is because people will thank you, so you'll be a bit less burnt out by the number of people asking you questions if they actually thank you for the work that you've been doing. Secondly, let's say you're dealing with an incident. Let's say a user has told you something you didn't know, and you found out that there's a whole bunch of other stuff. If you keep them up to date, if you are nice to them about their problem, they'll leave you to it. Like, all they want to know is that you're handling it, that that it's gonna get better. And finally, as I mentioned about Slack channels, they sometimes will actually help you answer other people's questions and deal with requests if they can, because you've been nice to them, because you've helped them with their issue, so they're more likely to go off and help other people. And finally, encouraging contributions from others. So in the case of Kubernetes, we tended to have a lot of kind of different deployment scripts, different deployment repos. And from time to time, people would want different specific features for how to get their stuff onto Kubernetes. I can't really think of one right now, but quite often they were kind of little issues, things that you could definitely fix, but that you're trying to prioritize your work towards what needs to be fixed for the whole, as in to reduce the amount of load that other people have. And in some cases, they might be things that, you'd need to talk to other teams about, for example. So if you encourage those people to do that work for themselves, then that means that they'll be happier. You'll have one less ticket on the bottom of your backlog, and can't think of other reasons. They'll understand your infrastructure better, I suppose. There's 3 things that you need to be able to do this. The first one is good unit tests. And I include things like bash scripts and deployment scripts, because if it's something to do with your infrastructure, that tends to be a little bit more scary. I mentioned earlier how infrastructure can be messy. And if you have someone from one of the team trying to contribute, then they could, in theory, screw up your infrastructure for the rest of your organization. And that's not something that they ever signed up for because they're on a development team. So having good unit tests is important because it will give them more confidence that they can do it without messing anything up. Secondly, patience. Probably more patience than you would need to deal with the rest of your team doing it. And this is because they don't have your context. They don't work in infrastructure. And they might need a little bit more hand-holding from time to time. But I promise it's worth it because it reduces the amount of work that you've got to deal with. And finally, communication. You need to be making sure that you're actually talking to them, if they've got a PR or MR submitted, they want to fix something, that you're actually going to review that for them, and you're actually going to give them some feedback on how they can improve in future. So in summary, stuff happens, shit happens. I think that it's important to try and avoid these kind of problems happening in future, but there's always a way to turn it around. It just might take you a little while to fix it. So thanks. I'll be around for questions later.
So we have the 2 tickets for the trainings. Who wants to have Kubernetes training? Okay. How are we going to do it? Like, I will need you 3 helping me out with this. What I'm going to do is to set a challenge for these people who want to train. Like, can you stand up? Who wants a training, please? It's going to be on the 8th of March, and it's going to be given by JetStack. I mean, I usually do Kubernetes training, and it's awesome, but apart from me, like the best people to have training is JetStack. Matt, can you stop talking and listen to me? I'm talking about your company, you know? Yeah, thank you. Can you stand up, please? Whoever who wants free Kubernetes training. If it's only 2 people, that's it. Okay, so what we're going to do is a little dance, and then you 3 tell me who won the competition. It's called. This is called delegation. Are you okay with the dance?
Oh yeah, let's humiliate all of us.
So we have 6 people. Well, you don't come and talk to me later, and then we will sort it out because I'm sure that Matt, say yes. Say yes. Say, come and talk to me afterwards, and then we'll sort it out. You don't have to do, like, you can do the dance now. Well, thank you very much for coming. This is it. We're going to do the pub. It's very late. The pub is just there. I always get lost.